All right, so you're welcome to class. So by the way, my name is Teacher Olumide, and the topic we are going to be looking at today is sorts. Now, what do we mean by sorts? So, for instance, if I write a number like 3, 5, 7, and I put a square root on them, you will find out that each of these numbers with the root on it, you can't directly find their square roots. So it is things like this, expressions like this, that we refer to as sorts. If we have a situation of root 4 is not a sort because it can be found, it can be simplified. But when it's such a way that it cannot be simplified further in any of this form, root 3, root 5, root 7, and so on, then it means we are dealing with sorts. So first of all, we are going to be looking at some the basic forms of sorts. The basic forms. The basic forms of sorts. So what do we mean by basic? We mean how can we simplify sorts in such a way that it will be smaller than what we are originally given. So for instance, if you see root 20 is not yet in its basic form. So how do I make it to be in its basic form? So what I'm going to be doing is that I'm going to be looking for factors of 20. When I mean factors of 20, I mean multiples of 20 that can give me 20 when I multiply them, but one of those numbers will be a perfect square. So this is what I mean. So for instance, square root of 20 is the same thing as 2 times 10. Square root of 20 is also the same thing as 4 times 5. Square root of 20 is also the same as 20 times 1. Now, if you look at 2 times 10, 2 is not a perfect square. 10 is not also a perfect square. If you look at the third one, 20 is not a perfect square. 1 is obviously a perfect square, but we can't use this context. But for 4 and 5, 4 is a perfect square and 5 is not. So because this one satisfy the condition we need, so we can then simplify and say square root of 20 is equal to square root of 4 times 5. And there is a law in sorts that states that if you have square root of A times B, square root of, if you have square root of A times B, the law states that this is equals to square root of A times square root of B. So it means that if I have square root of 20, it is equals to square root of 4 times square root of 5. That means square root of 4 is 2 times square root of 5 is 5. If I multiply these two entities together, 2 times root 5 is going to give me 2 root 5. So 2 root 5 is the basic form of root 20. 2 root 5 is the basic form of root 20. So that's what we mean by basic form of sorts. But obviously, nobody is going to give us a question like root 20 to just ask us to find. So let's take some questions and see how they can basically give us sorts to simplify in basic form. All right. So the first one we'll be looking at is if they give us a question like let's say root 20 plus root 45 plus root 125. Now, if you look at what we have here, it's not yet in its basic form. So what we are going to be doing, just like I said, is we will look for two factors of 20 in which one of it is a perfect square. We look for factors of 45 in which one of it is a perfect square. and you look for factors of 125 in which one of it is a perfect square. Now, to make this always easier for us, I advise that when you want to do for these factors, first of all, try to use 2 to divide that number. If it doesn't work, you try 3. If it doesn't work, you try 5. The reason why we are using 2, 3, or 5 is those numbers are prime numbers. So the moment you use 2 for this 20 now, if I use 2 to divide 20, that's 2 in 20 is going to give us 10. So that means 2 and 10 are both multiples of 20, but none of 2 and 10 can give me 20, so I won't go for that. If I try 3, 3 cannot go. If I try 5, 5 in 20 is 4. So straight away, I can say 20 is 4 times 5 plus. Now, square root of 45, just like I said, 2 cannot go. If I use 3 to divide 45, 3 in 45 is 15. That means 15 times 3 is going to give me 45. But I can't use any of those because none of those two numbers is a perfect square. So I can easily use 9 times 5 plus. Now, 125, the same thing. If I use 2 cannot go, so I can't use it. 3 cannot go. If I try 5, 5 in 125, that's going to give me 25. So I can easily say this is the same as 25 times 5. So from what I said is the rules of surds. So this is the same as square root of 4 times square root of 5 plus this is the same as square root of 9 times square root of 5 plus this is the same as square root of 25 times square root of 5. Square root of 4 is 2. That 2 multiplied by root 5 is going to give us 2 root 5 plus square root of 9 is 3. That 3 multiplied by root 5 is 3 root 5 plus square root of 25 is 5. 5 multiplied by root 5 is 5 root 5. Now, at this point, the next thing we are going to do is, if you look at this addition of this kind of surd, each of the surds we have is carrying root 5. So it means I can apply addition to this set of surds. And the reason why I can apply addition to it is they both contain the same surds. Root 5, root 5, and root 5. So what this means is 2 root 5, that's root 5 in 2 places, plus root 5 in 3 places, plus root 5 in 5 places. So 2 root 5 plus 3 root 5 is 5 root 5. 5 root 5 plus 5 root 5 is going to give us 10 root 5. So that's the answer to this question. All right, so basically this is how we solve simplify basic surds. So let's see if we can get another question on the basic form of surds. I'm going to be giving, after the whole class, I will try to give you guys question that you can do on your own, and at your leisure time you can find a way to submit them over to me. All right, so let's take another question. Let's simplify. Let's say 3 root 2 minus root 32 plus root 50 plus root 98. Now we've been asked to simplify this. Now, if we're going to simplify what we have here, just like I said, you look for factors on each side for what each of these things that has a root. That's root 2, root 32, root 50, root 98. So we look for factors. So 3 root 2 is already in its most simplified form. You can look for any other number. Now 32, 16 times 2 is 32. So we can easily use 16 times 2 plus root 50 is the same as 25 times 2 plus. Now root 98. Let's use 2 to divide 98. 2 in 98 is going to give us 49. That means 49 times 2 will give us 98. So we can easily use that. That's 49 times 2. So from here now, we now have 3 root 2 minus the square root of 16 is going to give us 4. That means that 4 is going to come outside of the root. So we have 4 root 2. The square root of 25 is going to give us 5. That's plus that 5 is going to come outside, plus the square root of 49 is going to give us 7 root 2. Now, just as we had the other time, each of what we get now is carrying root 2 on its own. So 3 root 2 minus 4 root 2 is going to give us minus 1 root 2, or just basically minus root 2. So 3 root 2 minus 4 root 2 is minus root 2. Minus root 2 plus 5 root 2 is going to give us 4 root 2. And 4 root 2 plus 7 root 2 is going to give us 11 root 2. That will be the final answer. A faster way to do some of these things is you can just easily use the coefficient of 3, 4, 5, 7. So you could just say 3 minus 4, that's minus 1, minus 1 plus 5, that's plus 4, plus 4 plus 7 is going to give us 11 root 2. All right, so those are just, in this aspect of simplification, it's pretty much easy. I think the difficult parts are usually where they ask us to rationalize denominators of sorts, which we'll soon get to presently. So let's just take one more question on this before we go to the next aspect of sorts. All right, so the next one is they ask us to find a and b. So we have 2 root 2 plus root 125 minus root 45 plus 4. Sorry, I made a mistake with the question. So it is not, it is 2 root 5. Okay, so we are told that this is equals to a plus b root c. Now the question wants us to find a, b, and c. So we are asked to find a, b, and c. So what we are going to do is, in this equation now, we have a left-hand side, we have a right-hand side. So by the time we are done with the left-hand side of the equation, we are going to be comparing it to the right-hand side. And that's going to help us find a, b, and c. So let's proceed. We have 2 root 5 plus, so let's simplify root 125, that's 25 times 5 minus 45 is 9 times 5 plus 4. So we have 2 root 5 plus square root of 25 here is 5. So the 5 is going to come outside. Root 5 minus the square root of 9 is 3. That's root 5 plus 4. So 2 root 5 plus 5 root 5, that's going to give us 7 root 5. 7 root 5 minus 3 root 5, that's going to give us 4 root 5 plus 4. Now, if you look at what they ask us to compare it to, we have a plus b root c. That means that a is the part that does not have any roots attached to it. And if you compare it to what we have in this situation, 4 is the one that satisfies that. So we can write our 4 first, plus b root c is the third part, which is the 4 root 5. So we have rearranged 4 root 5 plus 4 to look exactly like what they wanted. So if you now compare this, now you see that a is equals to 4. Sorry, a is equals to 4. Your b, that's what is beside the root sign. Your b is equals to 4 as well. and your c, that is what is inside the root, which is equals to 5. So very easy. So that's it about simplification of basic forms of sorts. So straight away, let's go into multiplication of sorts. How to multiply sorts together. Okay. Now, if we want to multiply sorts together, let's just take some principles that guides it. So for multiplication of sorts, one of the principles we need to know is that root A times root B is number one principle, is equals to square root of A times B. So when two sorts are given, you multiply their contents and you have your bigger roots. So number two, another law is if you have A times B root C. If you look at this now, A does not capture any roots and B does not also capture any roots. So it means that A will multiply the B. So it's A times B root C. So the answer here is AB root C. So anytime you have the multiplication of something that does not have a root, a number, times a number with a root beside it, you multiply those numbers, then the roots still appears. So the third law, another one is if I have root A times B, B root C. Now, if you look at this, the roots, anytime you have roots will always multiply roots. So there is an invincible one beside this root A. So that one is going to multiply B. That will give us B. Then root A times root C, that's going to be A times C. And that's going to give us B root AC. So anytime you are multiplying two sorts, their contents always multiply themselves, and the number that is outside is going to come outside repeatedly. So we have the fourth one. If I have A root B times C root D, so A is going to multiply B, root B is going to multiply root D. So that's A times C, that is AC. Square root of root B times D is root B D. So these four laws, I've compressed them, are going to guide us anytime we have a question related to multiplication of sorts. Yeah, so let me just quickly look for an example on this. Let's take one example on multiplication of sorts. All right. So we've been asked to multiply this with this. So that means I'm going to be using this first bracket here to multiply this second bracket. So we can say the content of this first bracket, let's first use root 2. Is going to be multiplying 5 root 2 minus 3 root 3. Then the second one, which is plus 2 root 3, is also going to be multiplying 5 root 2 minus 3 root 3. You close the bracket. All right, so root 2 times 5 root 2. Don't forget there is an invincible one beside this root 2. So that's going to be 1 times 5. That is 5. Now, root 2 times root 2 is going to give us root 4. Now, root 2 times minus, don't forget there's a negative sign here, so we can write that out first. Root 2 times 3 root 3 is going to give us 3 root 6, because the root 2 will multiply the root 3, and that's going to give us root 6. Plus the 2 root 3 times 5 root 2. 2 is going to multiply 5. That will give us 10. Root 3 times root 2. That's going to give us root 6. and the last part of it, 2 root 3 times minus 3 root 3. So that's 2 times minus 3, that is minus 6. Root 3 times root 3, that's going to give us root 9. So now root 4 is a perfect square, which is what? 2. 2 times that 5 is going to give us 10 minus 3 root 6 plus 10 root 6 minus, now square root of 9 as well is a perfect square, that's 3. 3 times 6, that's what? 18. So we can say this 10 minus 18. Okay, let's go to the next page. All right, so we can say 10 minus 18 minus 3 root 6 plus 10 root 6. So 10 minus 18 is going to give us minus 8. Minus 3 root 6 plus 10 root 6 is going to give us plus 7 root 6. So you can leave your answer like this, or you rearrange it and write 7 root 6 minus 8. So this can be your answer, or you leave it as this. So this is a basic example on how we multiply sorts. So let's take one more example on multiplication of sorts, and we'll go into rationalization of sorts. So let's multiply this sort as well. 7 root 2 plus root 3 multiplied by 7 root 2 minus root 3. So this is going to multiply, this bracket is going to multiply this. So let's first use the first part of this first bracket. So that's 7 root 2 open a bracket. So 7 root 2 is going to multiply 7 root 2 minus root 3, close the bracket, then plus root 3 is also going to multiply 7 root 2 minus root 3. All right, so 7 root 2 times 7 root 2, that's 7 times 7. That will give us 49. Root 2 times root 2 is root 4. Minus this minus sign, we repeat it. 7 root 2 times root 3, that's root 2 times root 3, and that's going to give us 7 root 6. Now let's go to the second bracket. Root 3 times 7 root 2. This sort part is going to multiply this. This sort part will multiply this. That's going to give us 7 root 6. Then the last one, root 3 times minus root 3 is going to give us minus root 9. And the square root of 4 is 2. 2 times 49, that's going to give us 98. Now minus 7 root 6 plus 7 root 6. If you look at this, minus 7 root 6 plus 7 root 6 is going to give us 0. Then we are left with minus square root of 9 is 3. So we are going to get 95 as our answer when we open the brackets. All right, so now we want to continue this class with rationalization of sorts. So in rationalization of sorts, what we mean is we want to be rationalizing denominators. Now we can do a brief study on what's rational and irrational numbers. So for instance, the case A we are going to be looking at is if you have a situation where you have A over sort B or root B, we are trying to make the denominator not to carry a root sign. So what we are going to be doing in this case is anytime you have something of this nature, A over root B. So to rationalize, because this root B is an irrational number, because you can express it as a fraction, two distinct fraction. So because we can't do that to root b, to make this irrational denominator rational, we are going to multiply both this numerator a and denominator root b by exactly the surd that is at the denominator. So that means this is now going to become equals to a over surd b times surd b over surd b. So a multiplied by root b, that will give us a root b. Now surd b times surd b is going to give us b. So don't forget another principle that we just need to take notice. If you notice, when you say root 3 times root 3, usually we write root 9 and it eventually still gives us 3. So that means anytime you have two sorts, exactly the same sorts, root 5 times root 5 will just give us 5. Instead of writing root 25, then later finding the square root of 25 to be 5. So that's what we did here, that root b times root b is going to give us b. So for instance, if you are given this sort to rationalize, we have 6 over root 7. What you just do is to say this is equals to this. You multiply both the numerator and the denominator by exactly the surd at the denominator. So we can say 6 times root 7 is 6 root 7 over root 7 times root 7 is 7. Please don't forget, this 7 at the denominator cannot cancel the 7 that is encapsulated inside this root. It can't cancel it because this root 7 is a surd, this 7 is a whole number. In mathematics, when we are dealing with things, it is whole numbers deals with whole numbers. You don't add what does not look exactly alike. So you leave this solution as 6 root 7 over root 7. So let's see another question. Let's see another question where they want us to rationalize. Let's rationalize 10 root 2 over root 5. So if we are going to solve this solution, you can just say this is 10 root 2 over root 5 times, that's surd 5 over surd 5. Now 10 root 2 times root 5, don't forget there's an invincible 1 here. That's 10 times 1, that's going to be 10. Root 2 times root 2, that's going to give you root 10 all over. Surd 5 times surd 5, that's going to give you 5. Now in this situation now, this 10 that is outside is a whole number. This 5 that is also outside is a whole number. So you can easily divide them. 5 here, 1 here is 2. So our final answer is 2 surd 10. Let's take the last one on this kinds of case A, where we are rationalizing the denominators. Okay. Okay, let's say we have been asked to find 20 all over 2 root 5. So what I can do in this case is that the same principle. You find out that this denominator now surd 5 is carrying a 2 beside it. So when I want to multiply both the numerator and denominator, all I still need to use is the surd 5. You don't need to carry the 2 along with it. Just use that surd component alone. That part that is carrying the root, that's surd 5 over surd 5. So we have 20 times surd 5. That's going to give us 20 root 5 over this 2 multiplied. Don't forget there's an invincible 1 here. That's going to be 2. Surd 5 times surd 5 is going to give us 5. So we have 20 root 5 all over 10. Cancel 0. Our final answer is 2. So 5. So I think at this point, we'll just stop the class. But before we stop, I'm going to take Before we stop, I'm going to take one of the why questions that might look a little bit difficult so that we begin to familiarize ourselves with how WAEC ask questions on this topic. So we'll just take one and we'll continue from there in the next class. So the question we have is 3 minus 6 over root 3 plus 3 over root 27. So we've been asked to simplify this. Now, if you look at this now, this part of the question, the 2 sub 3, it's already in its basic form. But these two other parts, the 6 over root 3 and the 3 over root 7, those parts are the parts we need to rationalize. But if you look at it very well, this sub 27, we can still reduce it to be in a basic form. So how do we do that? We say this is the same as 2 sub 3 minus 6 over sub 3 plus 3 over sub 27 is the same as 9 times 3. So this is the same as 2 root 3 minus 6 over root 3 plus all over. The square root of 9 is 3. So this is going to give us 3 sub 3. So at this point, we can now begin to rationalize. So this is 2 root 3 minus, let's use a bracket so that we don't make mistake. So we have 6 sub 3 times sub 3 over sub 3. Close the bracket plus this as well, 3 all over 3 sub 3 is going to be times sub 3 over sub 3. Don't forget, I'm only using this root 3 part to multiply both up and down. I don't need to use the 3 with this. So this is 2 root 3 minus 6 times sub 3 is going to give me 6 root 3 all over. Root 3 times root 3 is going to give me 3 plus 3 times root 3 is going to give me 3 root 3 all over. Now, be careful here. Don't forget the coefficient of this root 3 here is an invincible one. So that 3 times 1 is 3 times sub 3 times sub 3 is another 3. So this is the same as 2 root 3 minus 3 can go in 6. That's going to give us 2 root 3 plus this is 3 root 3 all over what? All over 9. So 3 here, 1. So basically, we can just say the LCM here, this is over 1 over 1. So LCM of 1, 1, and 3 is going to be, okay, let me use the next page. Okay, so 2 root 3, oh, sorry. The LCM of 1, 1, and 3, like I said, is 3. 1 and 3 is 3. 3 multiplied by 2 root 3 is going to give us 6 root 3. Minus 1 and 3 again is 3. 3 times this is going to give us 6 root 3. Plus, then this as well. 3 and 3 is 1. It's going to give us 3. So we can easily just say 6 root 6 minus 6. Sorry, 6 root 3 minus 6 root 3. That's 0. 0 plus root 3 is equals to root 3 over 3. I should have actually seen it right from here, but I didn't pay close attention. So if you look at this, 2 root 3 minus 2 root 3 would have given us 0. So this part would have given us the 0 we needed from the beginning. So you would have just been left with 3 root 3 over root 9. Then this answer would have still given us this. So these are just some of the basic simplification of sort. So by the time we meet again, or for the next video, I'm going to try to make another one for the case B part. This is where in rationalizing the denominator now, we use what we call conjugates, conjugates of a sort. And it's going to be a nice class when next we meet. Thank you for your time. Thank you for the opportunity to be a blessing to you all. God bless you. All right. So lastly, before we go, let me just give us some basic assignments, some question for us to lay our hands on. Um, so our assignments. So number one, just lay your hands on the question. Let's see, 3 with 45 minus 12 root 5 plus 16 root 20. So simplify this question. Number two, multiply this question together. 5 minus 2 root 3. Let it multiply. 6 plus 2 root 3. And let's see what we'll get. And lastly, we can rationalize this question. We can say 20 root 5 all over. Or let's take it this far. 20 over 4 root 5. And the last question, which is also a wire question. So just, you have to rationalize, but you simplify and rationalize at the same time. Then 1 over sod 2 plus 3 sod 2 minus 1 over 3 sod 2. So these are the questions I would love us to try and get back to me. God bless you. Thank you for joining up in the class.